Hello, everyone. Welcome to the 23rd seminar of the new Xylella seminar series. Today it is my pleasure to present Jesus Barreiro-Hurle. He works for the Joint Research Center for the European Commission. As you know, in 2019, it was the first time that the European Commission provided a list of priority pests for Europe, in which Xylella fastidiosa was ranked first. And during the following years, Jesus and his team in the Joint Research Center have been updating this list, modifying the R2P2 indicators, and also adding new data for covering different temporal dynamics and economic data. So today he will present the main outcomes of this exercise, as well as the web tool that you can use to search for these new indicators. Thank you, Jesus, and the floor is yours.
Okay, good afternoon to everyone, and thank you, Blanca, for inviting us to deliver this webinar. The work I am presenting is part of the activities of the Plant Health Economics team at the Joint Research Center in Seville, and I will be presenting, but everything that I'm showing has been the result of the efforts by Kevin Snyder, Estefania Vázquez Torre, Viola de Cori, and Emilio Rodríguez Cerezo, as well as of the plant health unit in EFSA that provided us with some data. Of course, everything I will be saying is in a personal capacity, and nothing can be taken as representing the official view of the European Commission. And the ERC is also a proud partner of the Bexil project, where many of you are also collaborating. So my idea is to, to present to you how we have updated the assessment of Xylella fastidiosa, and to avoid spoiler alerts, the title is quite straightforward. Xylella fastidiosa still ranks first in the 2025 update of the Priority Pest exercise. So as Blanca was mentioning, in 2019, as a result of a 3-year process, the Commission adopted the list of priority pests. This list was informed by work done by the JRC, again in collaboration with EFSA, and the list is presented in alphabetical order, but Xylella fastidiosa ranked first in our assessment. This assessment had some limitations. The biggest limitation being was that we had only studied 28 pests that had been put forward by the national plant protection authorities in the framework of the Standing Committee for Plant, Animals, Food and Feed. And the Commission was concerned that these 28 pests that had been assessed might not be the most dangerous pests in terms of economic, social, and environmental impact, because we have a list of over 400 union quarantine pests, and there might be something hiding there. So what did we do? You can imagine that to apply a data-hungry approach as the impact indicator for priority pests, the I2P2, is impossible when you have 400 pests. So we decided to use a shortcut or a less data-intensive approach to shortlist the pests that were included in the Union Quarantine Pest list. So basically, we did a semi-automated retrieval of the pest hosts. We tried to estimate the invasiveness of the different pests and calculated a risk, an indicator that combined the area and the production of the hosts that the pest could harm, and an idea of how probable or how much this pest would move if coming into the union. It's nothing related to actual risk or hazard. It's more related to hazard, and includes this invasiveness domain to try to arrive at risk. So once we shortlisted from these 400 pests a subset of these, we built the dossiers that we had done, well, that EFSA had done in 2019 for these pests. Some of them were new pests where we had to mobilize totally new knowledge. Others were just updates of the information that was gathered in 2019. Xylella will be in one of these cases. And then what we did is we updated all the data that we are using and calculated the indicators again and provided a new ranking. So basically, from 400 pests, we identified those that showed to be more risky. We analyzed those pests and we reach a new ranking. So if we start by the shortlisting exercise, as I mentioned, we couldn't do this study for the 400 pests. So we really needed to look for something that was ready available and could be automatized. And what we did is that we tried to make sure that this simplified approach somehow was correlated with the full-fledged approach. So we cannot apply all of our indicators, but ideally, this simplified indicator should align with a more in-depth analysis. Yeah? So we use this ranking to select a reasonable number of pests that could be studied using the original approach. So even trying to study the 394 pests that are in the Union quarantine list proved quite challenging because 175 of these 394 pests could not be analyzed. 20 of them because they were macro groups. So in the Union quarantine pest, instead of having a specific species as a pest, we have some kind of name that encompasses multiple pests. Then some of these Union quarantine pests are vectors that do not have any direct impact, and 90 of them had no hosts that were cultivated in the EU. So we are forgetting about pests, 90 of which are not relevant, but we are also forgetting about 20 macro groups that are really relevant and vectors that, despite not having an impact, if they were to enter the EU, they could spread some other pest. We matched the hosts for which there was evidence in the pest risk assessment of EFSA, of EPO, or INCABI, following this hierarchical order. And when we had these hosts, we looked for equivalence in national statistics, that in many cases is not so obvious. Of these 219 pests, for example, that we could study, nine of them had hosts that we could not find any data in the EU. And what we are doing is that we are taking a normalized invasiveness score that was provided by EFSA, and we also normalized the value of the hosts that could be affected by these pests or the area that could be that in which these hosts were planted, because we did not want only to focus on monetary values. We also cared about hosts that might not be so valuable, but they are very widely spread in the Union territory. So this analysis was done for 210 pests. So the process overview, as you can see, is identify hosts, match the hosts with statistical data, find the area and the value of those hosts, get some kind of measurement of invasiveness based on natural and human-assisted spread from EFSA, and create this very simple indicator. And when I say very simple, you can look at it. When we are doing the I2P2, we are mobilizing 25 indicators. Here we are just mobilizing 2, and the 25 indicators that are done for the I2P2 take into account a very specific parameter, that is the yield impact, that here is assumed to be unknown, and therefore we only think about the total value of production and the total area. So here are our results. This is very small, but you can see that when we are talking about the value of the hosts at risk, Xylella, which is in that red rectangle at the top right, not top left, sorry, ranks first when considering invasiveness and value of production, and it ranks ninth when we consider area. So Xylella affects large areas, but mainly areas where the hosts which the product are have a high economic value. So we took the 50 pests that were ranked highest considering value and area, and we ended up with 46 that meet this criteria. Of these 46, 23 are brand new, and 23 are part of the 28 that we assessed in 2019. The national representatives of the National Plant Protection Authorities decided that 5 of the pests that we had studied in 2019, it was not worth it to do the analysis once again. For example, Tiletia indica, which had a very small impact on wheat, grapevine flavescens doré, that was decided that in Europe we have learned to live with this pest, and 3 others. If we want to say what this means in terms of the diversity of pests, we can see in the first 2 bars that from the total number of pests that are listed as Union Quarantine pests and the pests that we consider to be in the top 50, either in value, area, or value and area, the proportion of the different kind of pests is quite constant. So if we have 55% of pests that are insects in the Union Quarantine pest, it's 50% of pests that we consider that pose the highest risk are also insects, and the same. However, when we move to the pests that we have analyzed, the share of insects increase dramatically. And why is it this so? Because here we are taking into account also the 23 pests that were originally proposed by the National Plant Protection Authorities. And it seems that National Plant Protection Authorities, when thinking about pests, were mainly thinking about insects. When you see a 2% of virus and a 2% of nematodes, de facto, what you are seeing is that we have analyzed 1 pest that was a virus and 1 pest that was a nematode, where in reality the number of viruses that are included in the Union Quarantine pest list is much higher. If we move into the update of the indicators, so what have we changed, not only on the pests that we have analyzed, but on how we have analyzed? We have a new scope, we have new data, and we have new indicators. The first thing that has happened between 2019 and 2025 is the fact that the European Union has changed its composition. So the UK is no longer a member of the EU, and trade with the UK, that in the past was not taken into consideration when calculating our indicators, now has to be considered when calculating this. We have also moved from data that was mostly from 2015 to 2017 to data that is from 2020 to 2023. We have also developed indicators for pests affecting trees. This doesn't affect Xylella so much because Xylella is considered a pest affecting crops. despite the fact that some of the hosts are also trees. And in the past, when we were analyzing the pests that were affecting trees, de facto, we were losing a lot of information because the indicators had been developed thinking on pests affecting crops. So, for example, we were talking about food security, and we were talking about the percentage of calories, fats, and fats that the hosts at risk represented on the diets. For trees, there was no production captured in the diet, so we had to look for something else. And also the whole environmental dimension that in the past had been developed by the JRC. During the last 4 years, EFSA has been working a lot on an ecosystem service-based analysis of the pests and the hosts. So we have a total new 5 indicators on environmental impacts of pests that was developed by EFSA. The second update was this review of the knowledge about new and old pests. And for this is the standard expert knowledge elicitation process of EFSA, where for all of these pests, they did a review to see which hosts should be included in the expert knowledge elicitation because they were really relevant. For these hosts, they would try to give us an estimation of the yield loss and quality loss when the pest had reached its maximum expansion in the Union territory. They also reviewed the expansion and the lag phase of the pests, how fast it moved, and how long does it take to detect it, what kind of time, and also as a proxy, not only the hosts that have an impact, but also the full list of the hosts that could be eventually affected by the pest. So zooming now into Xylella and taking the 2019 scientific report and the 2024 scientific report about Xylella, we can see what are the main changes in the scientific knowledge that EFSA has used. First, there's a change on the hosts that we evaluate. This is particularly so for olives and almonds. So we still evaluate the impacts of Xylella on grapes, both table grapes and wine grapes, and on all citrus crops. But while in 2019, EFSA thought that Xylella had a different impact on olive trees that were old and olive trees that were young, this time EFSA has managed to identify olive trees that are highly susceptible to Xylella and olive trees that are not, they have a low susceptibility for Xylella. And the main driver for being susceptible to Xylella at a high or a low level relates to the intensity of the production. And the intensity of the production is captured by whether olives are rain-fed or irrigated. Irrigated olive trees are more vigorous and seem to resist better the infection of Xylella, while rain-fed olive trees, are less resistant. And the same happens with almonds. In 2019, almonds were considered as a single crop, and in 2024, EFSA provides us estimates of impacts on rain-fed and irrigated almonds. If we want to see what this means in terms of yield impacts, for example, there's no change on the expected yield impact on table grapes of Xylella between 2019 and 2024. On average, it would destroy 0.5% of the production of table grapes in the Union. There is an increase on the damage expected on wine grapes. It actually multiplies by 6. So it's a 600% increase on the expected yield impact of Xylella on wine grapes. Nevertheless, the impact is not very high. It's still only 1.5% of the production of wine grapes. There's also a change in the impact expected for the low susceptibility olive trees. In the past, it was the young trees. Now it's the irrigated trees. So the yield impact goes down from 35% to 24%. It's not only an issue of having better knowledge on Xylella, it's also a different definition of what is high and low susceptibility. And the same happens for the impact on the high susceptible olive trees. It goes down from nearly a 70% yield loss that was given in 2019 to 60%, which is still a very high yield loss if Xylella is to attack or to infect an olive tree. If we are looking into almonds, in 2019, the impact was expected to be approximately 13%, and in 2024, doing the average of the high and the low version, we get approximately 25%. So we have also seen that the knowledge that we have regarding the yield impacts of Xylella on almonds has led to identify a higher potential damage potential. And last but not least, on citrus, we see a small decrease on what is the expected damage that Xylella will do to citrus production, going down from 11% to 10.3%. The other thing that we have also updated the information is about the spread rate. In 2019, it was believed that Xylella could spread at an average of 5 kilometers per year. In 2024, this has been reduced to 2. And in 2019, the knowledge we had about how long it would take to detect Xylella once it's present was approximately 3 years, and now it's closer to 5 years. Regarding how to treat them, in 2019, the description that EFSA gave was that only integrated strategies combining different tactics can be envisaged to control Xylella. In 2024, there's a more nuanced saying that substantial change in the control strategy is required with the use of new pesticides or integration with other agricultural and control practices that could further increase the environmental impact. So we believe from the I2P2 perspective that the undesired effects of the pest being present related to its control measures for Xylella is in the highest category of potential risks. The distribution of Xylella around the world has also changed. It's now present in Israel and Lebanon, in addition to the countries where it was before, and it has also changed its quarantine status, and it's no longer a quarantine pest in Argentina or Brazil, but has been declared a quarantine pest in Egypt, Georgia, Israel, Jordan, Moldova, Morocco, New Zealand, Tunisia, Switzerland, and the United Kingdom. This is very important because when we are calculating all the international trade impacts, we believe that no country where they have declared the pest present and has not declared the pest at quarantine would ban the imports of products from the EU if Xylella were to be established. So in the end, our new model version has two, besides all this underlying data, has two methodological changes. The impact in the social domain for forestry, where we are looking now at wild forest products and the income that wild forest products generates for households, and on the capacity to fixate small particulate matter, so in PM 2.5, because if the trees were that die because of a pest disappear, there would be an increase of particulate matter, and that particulate matter eventually will have an impact on health. And on and on environmental impacts, we now have this specific ecosystem service impact developed by EFSA. We are also looking at the kind of species that live in the habitats that would be attacked by the pest. And we keep these two indicators on the increase of the use of plant protection products and the share of of the host under Natura 2000. If you want more details on that, I invite you to reach out to EFSA because I'm just trying to summarize what I've read. And in this part, yes, you have more. If you need more information about exactly what it means, these new indicators for trees, please reach out. Again, the indicator is aggregated from right to left, so from indicator to subdomain and to domain, assuming equal weights and also assuming that there is no priority given to economic, social, or environmental. And irrespective of the number of domains or the number of indicators, everything has the same weight when trying to consider this. However, this analysis that we've done in 2025 also includes a sensitivity analysis to weights that I will also show afterwards. So if you want to know what all these changes mean in our indicators, so if in 2019 we had estimated that the total value of production at risk was 5.5 billion euros, in 2024, this figure still increases to 7.1 billion euros. So update your references when you are publishing your papers on Xylella. The maximum value of production that could be lost if Xylella were to expand in the Union territory is 7.1 billion. We also see that despite this increase in value, the share of total production that would be affected decreases. Yeah. So we have here some funny finding that we have more value at risk, but if all this value disappeared, we will still have more production in Europe. And in terms of job losses, now we are talking about nearly 500,000 job losses, or over 500,000 job losses that could be lost if Xylella were to spread in the Union. With this new data, we have rerun all the analysis now with these 46 pests. And if we focus on the pests affecting crops, this is the slide that justifies the title of my presentation. So Xylella still ranks first when we are considering the pests affecting crops using the I2P2 approach that was developed by us. From this slide, you can also see that on the top 6 pests, 4 were already analyzed in 2019. So somehow the National Plant Protection authorities identified pests that were really important. But you can also see that they overlooked or didn't think of other pests that once you analyze them in detail could be really important, like Listronotus bonaerensis or Spedoptera litura. If we want to see if our analysis in 2024 is in line with the analysis of 2019, the first thing that we see is that 50% of the pests that were analyzed in the past remain in the same order. And this relates also, which is important, to the 5 pests that had the highest value. So Xylella fastidiosa, Popilia, Taumatotibia candidatus, and Conotrachelus are in the same rank now as they were in 2019. However, we see that there are some pests that are more impactful in 2024 than they were in 2019. And for example, for Spodoptera frugipedra, we see that new species have been added as hosts. In some of these species where it can be a host, it's capable of producing mycotoxins, and the EU trades with more countries. So this affects why we consider this pest to be important. And for example, for Philostica citricarpa, the yield impact has increased significantly between 2019 and 2024. So new knowledge that has been provided by science demonstrates that it can be more harmful than it was in 2019. And we also have some pests that now are less important, or we believe that there are other pests that have a bigger impact. In the case of Autonomous eugeni, the yield loss has decreased for some hosts, and also the lag phase and the expansion rate have decreased. So it doesn't move as fast, and it takes less time to detect it. In the case of Anastraphera ludens, some hosts have been reduced. So from these 3 slides, what we want to show is that despite the updates that we have done in the indicator in terms of new data and changing some of the, or changing the environmental indicators that are now provided by EFSA, the ranking is still quite consistent. The second part that I was talking to you about was this assumption of giving the same importance to everything in the indicator. Many people believe that economics shouldn't be the most important. Other people believe that economics should be the most important and we shouldn't care about social. Other people think that environment is more important. So what we've done basically is calculate the indicator for any distribution of importance. So from giving only importance to economics to giving only importance to the environment and anything in between. And by calculating the rankings for each pest and each weighing strategy, we can see 2 pests that really have the potential to have the highest impact independent of what we consider that it's important. And this is Xylella fastidiosa and Listernotus bonaerensis. Some other pests here in the middle part of the distribution can be higher or lower depending on the importance that you give it. For example, Popilla japonica can really be the second pest if we give the highest weight to production, for example. And when we do this analysis, we can see which is the maximum rank that a pest would reach with any of these analysis. So Xylella and Listronotus could be the most, well, I mean, Xylella de facto is the most impactful pest if we consider the equal weights, but under some circumstances, giving more importance to, I kind of remember, to the social domain, Listronotus bonaerensis could rank first. But then there's other pests that it doesn't matter what importance you give to any of the domains of our indicator, that they will never make it beyond position 20. For example, Acteris minuta, Keiferia licos pericicella, you know that these pests, I don't pronounce them so much, so I don't know them so well. And for each of the pests, we have done this kind of spider graph where you see the distribution of the impacts across the 3 dimensions. And the more similar this graph is to a triangle, the more I would say, consistent impact across all dimensions. So Xylella and Listronotus would have this kind of triangle because irrespective of where you focus, they score high. And then some of these pests that reach number 3 despite being number 10 is because they rank very high on environment, social, or economic. This is only a snapshot of what we've done. And if you want to know more, you have two main sources of information that are now public. The first one is the report, and the second one is the indicators. And let me finish my presentation by showing you live some of the facilities of this visualization that we have done. Skip verification. You should be seeing now, hopefully, my screen with a web browser. Is that correct?
Yes.
Oh, okay. Okay, good. Thank you. Yeah, you
It's
have
coming.
here.
Yeah. Mm-hmm.
You have here the user manual in case you want to understand better. But we open the dashboard by default with Xylella. And here, for example, you can see an overview of the score. As I was telling you, it's quite balanced. 37% of the impact is social, 35% is economic, and 28 is environmental. You can see here how it ranks. The gray area is the total distribution, and Xylella is number one. It has 9 hosts. You can access the EPO website. You can access the EFSA report, and you can say and access our report. And from the main page, you can also go to any of the indicators. So let's try to see what is the impact on production. Here you see the 7.1 billion euros that I mentioned, most of which comes from the production of olives, followed for grapes for wine, citrus, almonds, small citrus, limes. Here you can see the distribution by country, and you can also get it in a table format. So if you want to know what is the risk, what would be the losses if Xylella attacked almonds in Bulgaria? And if you go here to Bulgaria, you have the total sum of losses that would be 1.1 million. And here you can see the distribution by crop, olives, almonds, etc. The second thing that you can do from here is do this sensitivity analysis yourself. You can go here, and by default, the indicator is calculated assuming 1/3 in economic, 1/3 in social, and 1/3 in environment. So let us assume for one moment that you don't care about the environment and you don't care about social, you only care about the environment. Yeah. So Xylella would still be would fall to pest to the third rank because Listronotus bonaerensis and Popillia japonica have a bigger impact in terms of the environment than Xylella. Spodoptera litura, that was initially our pest ranked fourth, would fall down to the 10th place because it even has a lower environmental impact. And you can do this for any combination that you want, and not only at the top level, but also at the different sub-levels. So you could think that, okay, I still believe that economics is important, but I don't care about trade, I don't care about prices, and I don't care about upstream and downstream effects. I only care about production. So you could insert a 1 here, and then 0 here, 0 here, 0 here, and 0 here, and you would get the ranking if production was the only important thing. And if production was the only important thing, Popillia japonica would fall one place. And the last thing that you can do with our visualization is to compare two pests. So for example, as I was telling you in Girona, just imagine that you go to a conference on plant pathology and someone tells you that Xylella is not so important, that Trips palmi is much more important. So you could actually show to them that in terms of potential production losses, that is not the case. In terms of the value of production affected, it's not the case. And de facto that Xylella ranks number 21 and Trips palmi, despite being a very nice bug, only ranks 21 out of 28. So with this, I will finish my presentation. I hope that I've raised sufficient attention so you all visit our report and our online visualization, and I'm available for questions that you might want to have. And for that, I will show my face and stop sharing my screen.
Thank you, Jesus.